Welcome to this explainer. Today, we're diving into why the computing world is shifting from electrons to light. Because here's the thing, our traditional silicon chips, they are hitting a hard physical wall. Moore's law is literally dying. Transistors are so tiny now, they leak electrons, causing insane heat and power drain. To put that in perspective, by 2030, Texas data centers alone will demand a staggering 78 gigawatts of power. To solve this huge energy crisis, we're replacing electrical signals with light to process and transport data. It's actually wild. The whole system relies on just 4 simple components to generate, route, modulate, and detect light. So, how do they actually compare? Let's kick off our head-to-head matchup with processing speed. Electronic processing is like a single-lane toll road. Data constantly stops and starts, waiting for clock cycles. But photonics, it's a multi-lane superhighway. Different colored light waves travel simultaneously without ever crashing into each other. This parallel flow means we get a mind-blowing latency of just 200 picoseconds per calculation. Next up, let's look at energy and heat. This is where the efficiency differences get truly insane. Moving electrons is like shoving through a packed hallway. You hit resistance, creating massive hardware melting heat. But light, it's like flying through an empty tunnel. Zero friction means practically zero heat generated. This frictionless setup is incredibly efficient, using as little as 0.05 picojoules of energy per bit. That translates to an absolutely staggering 262 trillion operations per single watt. So yeah, across throughput, heat, and interference, light completely crushes the old physical limits of electronics. The huge AI advantage, complex matrix math, happens natively just by shining light through optical interferometers. And this isn't science fiction. We are moving toward a full photonic stack by 2030. We won't ditch silicon entirely, though. Standard chips will handle general tasks, while light accelerates heavy AI. The silicon transistor defined the last 60 years of computing. What comes next is up to us. So, I leave you with this. Will our next decade of computing be defined entirely by light?